Okay, good evening. This is Professor David J. De Los Reyes. Okay, my topic for this evening will be lesson number 27. This is simplification of radicals and the rationalizing of a denominator of a radical expression. Okay, let's proceed. This is a long video format, and this is for those people who are taking college algebra. We are running smooth. We are now on lesson number 27. Okay, just don't be bored. We run smooth. We could finish this college algebra. Okay, let's proceed. The subject matter for this evening will be long video format discussion, and this is college algebra lesson number 27. And the title of the topic will be simplifying radicals and rationalizing a denominator of a radical expression. So meaning simplification of a radical expression and the method on how to rationalize, okay, the denominator of a radical expression. Okay, let's proceed. There are certain properties which we must have to memorize under the so-called simplification and rationalizing. There are only two. It is the product of a radicand and the other one is the so-called quotient of a radical expression. The number one equation is actually, if we try to read this one, okay, let's try to have a review first. This is a radical sign, right? This is the index. The terms inside the radical sign is actually the radicand. So it could either be one term or two term, but for this topic here, there are two terms inside the radicand. So the first one is the nth root of the product AB. Nth root. If we try to read this one, the nth root of the product AB, if we try to simplify this should be equal to the nth root of the first one times the nth root of the second one. The first radicand is A and the second radicand is B, and their index is same as n. So if we are given the nth root of the product AB, this could be simplified to the form the nth root of A times the nth root of B. As simple as that one. The next one, this will be under quotient. The nth root of the quotient A over B. There are two radicands inside, and unluckily the operation inside is division. On the first one, it is multiplication. On the second one, it is division. So if I will try to read this one, okay, the nth root of the ratio A over B, this should be equal to, we could simplify this one as simply the nth root of the numerator, okay, all over the nth root of the denominator, right? The denominator radical is actually B, so the nth root, it should be the nth root of A all over the nth root of B with the given condition. The radicand B should not be equal to 0, because just in case radicand B is equal to 0, that's another thing, okay? Okay, those are only the two properties which are needed in the so-called simplification of radical expression. That is the nth root of the product and the nth root of equation. Okay? For the product, just take the nth root of each, multiply it. And for the division, just take the nth root of the numerator divided by the nth root of the denominator, but you must have to simplify it. Okay, let's try to bring out the rules on how to simplify radical expression. For us to say that the radical expression is already in the so-called simplest form, there are three conditions that must be satisfied. Number one, for it to be in the simplest form equivalent already, okay, I will try to read it. All possible factors are done, or it's done. We factor that already, and we bring it out from the radical sign. That's number one. no radicals contain a fraction. If there are still radicals, okay, it should not contain a fraction for it to be in the so-called simplest form. And number 3, no denominator of a fraction contains a radical. So meaning to say, if there is a fraction, on that fraction there should be no radical sign for it to be considered in the so-called simplest form. So we must have to satisfy these 3 conditions here for us to say that the given expression is already expressed in the so-called simplest form. Okay? Because the the concept of the topic for tonight is how to simplify, right? So for it to be in the so-called simplest form, we must have to satisfy these 3 conditions here. All possible factors are done, and all factors are out from the radical sign. And no radicals contain a fraction. Okay? Meaning to say, if you still got a radical sign, there should no be fraction inside. And for what they call this condition number 3, no denominator of a fraction contains a radical sign. So if there is still a what they call this denominator, for that denominator, there should be no radical sign. Okay, let's try to bring out an example. Oh, this is an easy one. This has been coming out from the short videos online on YouTube. There are lots of these, okay? So some of my co-bloggers try to illustrate on how we operate on the 2 properties. Okay, example number 1. Simplify the square root of the product 9 times 4. We got a radical sign, right? And the index is not specified. Like what I said from the previous lesson number 26. If the index is not given, it is understood that the index is actually 2. So this is actually square root. Okay? So the given problem is, it's just a radical sign, the product of 9 times 4 inside. So meaning to say, we are asked to simplify the product of 9 times 4, the square root. Okay? Okay, let's try to bring out the solution. 9 could be factored out into the so-called, its prime factors of 9 are the product 3 and 3, 9 and 1. Of course, 9 and 1 will be excluded because they are not perfect square, right? And 3 and 3, if we try to multiply it, it's a perfect square. So I place it here. 9 can be written as the product of 3 times 3. And the value 4, okay, it's either 4 times 1 or 2 times 2, but we exclude 4 times 1. So we will just consider the prime factors 2 and 2 because 2 times 2 is 4. And 2 square is actually a perfect square. Okay, so if we try to simplify the square root of the product 9 times 4, this should be equal to the square root of 9 times the square root of 4. We use property number 1. That is the square root of AB should be equal to square root of A times the square root of B. Right? We use this one. For this given problem, the value of n is equal to 2, right? That's why we place it here, it should be n, so n could take any value from 2 going up. Okay, but for the given example, it is a square root. Okay, I will try to erase this one so it will look good. Okay, let's try to simplify. So the square root of the product 9 times 4 can be written as the square root of 9 times the square root of 4 by using property number 1. And if we try to write 9 from this, 9 can be written as 3 squared, right? And 2 can be written as 2 squared. So if we try to simplify this one, it seems we are on the short videos on YouTube, okay? But for tonight, this is a long-form discussion. 9 can be written as 3 squared, right? This is square root, so this is raised to 1/2. Times 4 can be written as the product of, or the value 2 square, again raised to 1 half, because this is square root, this is square root. Square root is actually raised to the 1 half, square root, this is raised to the 1 half. Then we try to use the so-called laws of exponent. Okay? 2 times 1 half is 1, so because these two here cancel with this, and these two here cancel with this. So the exponent of 3 in 1, after the cancellation, the exponent of 3 is actually 1. This is times 2 raised to the first power. Okay? But since this is square root, it could either be plus or minus 3 for the first one. Second one will be plus or minus 2. Okay? Then try to take the product. A plus in a plus, it will be plus. A minus in a minus, that will still be, it will still be plus. Plus 6. Right? So the answer is actually the simplification of the square root of the product 9 times 4 is actually 6. And that will be our answer. And obviously, if we try to square 6, that's 36. Because 9 times 4 is 36. But the proper way on how to simplify by using our knowledge of radical expression, it will be something like this. We will express the first one as a perfect square, then we take the square root. We express the second one also as a perfect square, then take the square root, then take the product. So what comes out is 6. So the answer will be 6 for this example number 1. Example number 2, for simplification. Simplify the given radical expression is, the index here is actually n is equal to 4, right? Right? So we are taking the fourth root of the product inside the radical sign, which is 243. This is x to the 8. X to the 8. This is x to the 8 power. Right? Times y to the 10. Meaning to say, we must have to simplify the product 243 x to the 8 y to the 10th power if we try to take the fourth root of that one, because the value of n for this second example is n is equal to 4. Okay, let's try to bring out the solution. 243 can be written as the product of 9 times 7, right? Then we try to simplify. 9 is still factorable to its prime factors, the product of 3 and 3. And 27, it is actually the product of 3 times 3 times 3. So this will be again 3 times 3 times 3. So if we try to look at the resulting right hand side, this should be 3 raised to the 5th power, because we will multiply 3 5 times by itself, and by using the laws of exponent, this should be 3 raised to the 5th power. So if I will try to rewrite the given original radical expression, okay? See, the operation inside is multiplication, right? So actually, I could write 3 to the 5th power as the product 3 times 3 to the 4th, right? So if I will try to write 243 as the product of 3 times 3 to the 4th, this is actually 3 times 3 to the 4th times x to the 8 times y to the 10th power. And by using property number 1, the operation inside is multiplication, okay? So actually, it should be the, what you call this, the fourth root of the pure number 243 and the fourth root of x to the 8 times the fourth root of y to the 10. We are using property number 1. For this example number 2, there are 3 radicals, right? So if there are 3, there should be 3. If there is 2, if there are 2, there should be 2, right? So they should be, if we try to expand now, this should be the fourth root of 3 times the fourth root of 3 to the 4th. Because 3 times 3 to the 4th is actually the first one, right? So if we try to take the simplification, it should be the product, right? The fourth root of 3 times the fourth root of 3 to the 4th times the fourth root of x to the 8 times this y square. It can be written as the fourth root of y squared or y to the 8 times y squared, the fourth root. Because y to the 8 and y squared is actually y to the 10th. Right? Y to the 10th can be written as y squared or y to the 8 times y squared. Right? Let's try to express the simplification of the right hand side in terms of the preparable fractional exponent. The fourth root of 3 can be written as 3 raised to 1/4 multiplied by, this is 3 to the 4th. We are taking the fourth root, so this is again raised to the 1/4. The next one is x to the 8. We are taking the fourth root, so this is raised to the 1/4. Meaning to say x to the 8, raise that again to the 1/4 power. And the next one, this falls under product. So it should be y to the 8 raised to the 1/4. Next one will be y squared raised to the 1/4. Then try to make a simplification. This 4 and 4 cancels, right? So this will now be only 3. For 3 to the 1/4, for the meantime, we could not do anything about it. For x squared or x to the 8 raised to the 1/4, 8 over 4 will be 2. So this will now be x squared, right? And for the next one, for this y to the 8 raised to the 1/4, 8 over 4 will be 2. So this will now be x squared. Okay? The last one, y squared, we will take the fourth root of that one. We could not do anything about it. It will still be y squared raised to 1/4. Okay? So what will come out? This is 3 is not got no perfect fourth root, and y squared is doesn't have also a perfect fourth root. So we put it under one radical sign with the index power 4, and the resulting multiplicand on the first one will be 3x squared y squared. So the final answer will be 3x squared y squared and the fourth root of 3y squared. We combine this one already in this one. Okay, their index is 1/4, right? So this is 3y squared raised to 1/4. So the final answer will be 3x squared y squared, the fourth root of 3y squared. That will be our final answer. Okay? So actually, if we try to express the simplification in terms of the so-called fractional exponent, we could visualize it. It is something like this. 3 to the 4th raised to the 1/4, 4 times 1/4 will be 1. So actually this cancels. Right? So what remains will be 3. And x to the 8 raised to the 1/4, 8 over 4 will be 2. So actually the power of this one now will be x squared. Right? It will be x squared. To the simplification. And y to the 8 raised to the 1/4, okay, this cancels. The power of y now will be simply y squared. Okay, so you can see it, it's cleaning up. The perfect fourth roots are actually 3x squared and y squared. So that's the first part of the final answer. And the terms that are not a perfect fourth root is actually 3 and y squared. So we put it under the radical sign, 3y squared, and this should be the fourth root. Final answer, 3x squared, y squared, the fourth root of 3y squared. That will be the final answer. Okay? The next topic for tonight will be the rationalizing of the so-called denominator of a radical expression. Rationalizing meaning there is a, what they call this concept on this one. We will multiply both the numerator, capital letter N is numerator, and D, capital letter T will be denominator, creates a perfect n power. To rationalize a radical expression, okay, we will multiply both the numerator and the denominator for us to give us a perfect n power. Okay, let's try to visualize this n power that is being placed on the definition. To visualize this one, we will give an example. Rationalize the denominator of the radical expression, the fifth root of the ratio 4 over x squared. right? This is 4. Sorry for this one. So the given radical expression is actually under division. It falls under property number 2. The value of n is equal to 5. Okay, so if we try to simplify this one, okay, I will follow property number 2. So the fifth root of 4 will be the fifth root of 4 all over the fifth root of x squared. And according to our definition of the so-called rationalizing the denominator, we will rationalize this one. We will multiply the given radical expression by a terms in which, when we try to simplify, the power of the denominator will be a perfect n power. So for it to be a perfect n power, right, the value of n is actually equal to 5, right? Right? So for the denominator to be a perfect n power, this is now an x squared. So the radicand for the multiplier should be an x cubed, because x squared times x cubed is actually x to the fifth, right? And if we try to take the fifth root of this, right, fifth root, 5 times 1 over 5, 5 cancels, so what will come out for the power of the denominator now will be a perfect power. And the value of x is 1, and for the value of the n power for the denominator now is actually 1, or just simply x. So the proper multiplier for it to be rationalized, it should be multiplied by the fifth root of x cubed times the fifth root, or all over the fifth root of x cubed. Because actually, this value here is actually 1, right? But we could do it. We could insert it, right? We multiply the numerator and denominator by the same quantity, will not change the value of the algebraic expression. But we could do it because we are rationalizing. So if we try to simplify this one, the fifth root of 4 times the fifth root of x cubed, okay, we'll combine this one now. We'll use property number 1. We'll go back. So we will multiply 4x cubed. So this will now be 4x cubed. This is power 5, this is power 5, so this is power 5, right? And for the resulting denominator, it will be, we multiply also the radical inside, x squared times x cubed. So this is under one radical sign, x squared times x cubed, right? This is with the power 5. So this should be x to the fifth raised to 1/5. Okay? So what will come out? This should be the fifth root of 4x cubed all over. If we try to convert this into a fractional equivalent, it should be x to the fifth power raised to 1/5. And luckily, this 5 here cancel with this. So what comes out for the final answer will be the fifth root of the product 4x cubed all over x. So as you can see it, after the multiplication of the fifth root of x cubed, for both the numerator and denominator, okay, what comes out for the power of the denominator was a perfect number. Okay, it is an exact number. It could be 1, it could be 2, it could be 3. But for this given example, it is x. Just simply x to the first power, or just simply x. So the final rationalizing answer for this one will be the fifth root of the product 4x cubed all over x, and that will be our final answer. So that's the way how to rationalize what you call this a radical expression. Okay, last example for tonight. Rationalize the given expression 1 over square root of 3. We've been seeing this one under the study of trigonometry. 1 over square root of 3. The given denominator is actually got a radical sign. So if we try to rationalize this one, 1 over the square root of 3 can be written as 1 over square root of 3, right, times square root of 3 over square root of 3. Then 1 times square root of 3 is actually square root of 3, right? And square root of 3 times square root of 3 is actually exactly 3, right? So, meaning to say, after multiplying the given radical expression by square root of 3 over square root of 3, the power of the term under the denominator was an exact number. It is 1, right? So it is actually 3 to the first power. So the equivalent of 1 over square root of 3 after the rationalizing will be square root of 3 over 3, and that will be the final answer. Okay, that's it, guys. That's the proper way on how to simplify and rationalize a denominator under the so-called study of radical expression. So for you guys who are studying college algebra, this is for you. If you want to subscribe to my channel is at youtube.com/@proofdvj. If you want to share it, please click share. Okay. Try to watch my long video format discussion on college algebra. I am promising you, you will learn something from it. Okay, good evening from Los Angeles, Professor David J. De Los Reyes.